Hey, so what's up, my people? We got our first question here. There we go. Let me just put that in place with my lovely magnetic bits of, I don't know what they're called, but they hold a piece of paper there, so it's awesome. So I'm loving that. Thank you, Cathedral Products. So we've got our, now let's zoom in a little bit so you can see it. There we go. Happy days. Right, so we have got this problem. It is a 3-mark GCSE question, alright? So it's one that we don't want to be throwing away any marks on. It says to find the equation of the line L. And this is the line called L here that's going through these axes. And I've got to decide what to do. What I do know is the equation of a straight line that's diagonal has an equation that looks similar to y equals mx plus c, yeah? So I know that, and I've got to get that into place somewhere. I know the y will stay as y. I know the x will stay as x, so I can just, I know that one and I know that one. I need to work out the m and the c. I know the c is where it crosses the y-axis. So I look at my line, and it cuts the y-axis at this point here. Boom, at 5. So I know then that c is 5. So I'm going to write that down here. It cuts the y-axis, so my c is going to equal 5. So the only thing left to calculate now, folks, is the gradient of the line. I know that as I look from left to right, the line is sloping downwards. Yeah? So that's going to tell me some information. It tells me that my m, my gradient, is going to be negative. Yeah, because it's sloping down. So I know when I get my answer, if it's not negative, I've gone wrong somewhere. So that's something to notice. Alright, let's have a look at finding this gradient. In other words, how do I describe how this line slopes? So, take 2 points on the line that you can see clearly. So I'm going to go for this point here and this point here. So I'll pick 2 points that I can see clearly on my line. Now, what I'm going to look at is what happens in the differences of my x and my y by making a special little right angle triangle for you to see, which goes something like this. So here, using my 2 points, I have created a right angle triangle. I hope you can see that clear enough. Thus the width, oh my gosh, my phone died, no! Sorry about that, we just had the phone nearly fell on the floor, which had been a bit of a problem, but never mind, we saved it. So we're looking at the width of this triangle. So the x, the horizontal line here is 1. The vertical line, the height of the triangle, is 2. So what I do is some maths where I take the difference in the y, so the 2, the difference, I'm going to put d for difference in the y, in the height of it. I'm going to divide that by the difference in the x. And later on you'll see this shortened to dy over dx, which means how the y differs in comparison to how the x differs. So let's have a look at that. We've got 2 on the x-axis, on the y height, sorry, and we've got 1 on the x, on the width of the triangle. So we're going to, so our maths here would be 2 over 1, or 2 divided by 1, which is 2. So m equals 2. So let's collate all this information together. It has to look like this. C is 5, m's got to be negative, and I've calculated m to work out to be 2. So therefore I know this needs to be negative 2 for that to work. And my final answer, therefore, to get my 3 marks, the equation of that line is y equals negative 2 x and then plus 5 for the c. Okay, so that is how I work out that problem. I hope that was clear enough. Sorry about the issue with the phone falling over, but hopefully that's good. I've got a few more questions for you. We're going to go through them together. Hi there. Okay, so I've got you another question here. It's one that's written in a slightly different way and has multiple parts, but we still have to use our same ideas. So is that it's a bit too far away, can't it? So let's zoom in a little bit so you can see clearer. So what it says here, Zoom in. So what it says there is that the line with equation x plus 2y equals 6 has been drawn on the grid. And there is a line drawn on the grid for me. Nice and simple there. And then later on down the bottom it says I've got to rearrange the equation x plus 2y equals 6 to make y the subject. So that is really nothing to do with equation straight line, but more about making something the subject. So let me just zoom back out a little bit, back out a second, so you can kind of see my maths. So what I'm going to take that equation, x plus 2y equals 6. If you can see that, yep. And I'm going to leave the equal sign where it is, because like I told you, it's all about keeping the equal sign where it is and moving things about. I want the y to stay where it is, so I'm going to keep 2y at the moment and subtract x. So 2y stays there, and this becomes 6, take away x on that side. Then I'll keep the equal sign in line again, and here I'm going to divide by 2. That leaves y on this side, and 6 over 2, which is 3, and take away x over 2, which is x as a half x, whatever. Alright, so that looks really awkward, little weird thing there. But if I simplify that even further, I've got y equals, this becomes 3, and then that's take away a half x. Right, just so you can see clearly, I'm writing it in very close to this y equals mx plus c form, just so I can show you what's going on. So let's have a look at this now. It's been written slightly differently, but let's just have a look and have a play with this here. By the way, that's the answer to that question. I've rearranged it so y is equal to this. That is also the answer to the question. I could have just put divide by 2 completely on that. That's the problem. As long as y is on its own, I have answered this question. Here it says write down the gradient of the line with the equation of this. So with this equation. So I'm going to write down the gradient of this line. Looking at this, and looking at this problem here, and this one here, I can see that the number that is in front of my x, the coefficient this is called, that's in front of my x, is the one that describes the gradient. So looking at this problem here, as long as I've got a y on its own, what I have here is mx plus c. It's just written the other way around. So this negative a half is the gradient that I'm looking for. So m is negative a half. It drops down, it slopes negatively. This is positive 3, so my c is positive 3. It cuts the y-axis at the point, it cuts y-axis at the point 0, 3. Yeah, it does, see? So by rearranging an equation that's written in a different format into a format that is pretty much y equals something, we'll be able to see the m and the c from our thing. All right. This bottom question down here, write down the equation of the line which is parallel to the line with equation x plus 2y equals 6 and passes through the point with coordinates 0, 7. Right, so it's written small and I'm not zooming in. I'm not zooming in on purpose because I'm going to extract from the question the important information. So, write down the equation of the line which is parallel to the line of the equation x plus 2y equals 6. So the line I'm looking for is going to be parallel to the line that we've been working with so far, x plus 2y equals 6. Alright, so that's the bit of information from there. It also passes through the point 0, 7. So it passes through the point 0, 7. Okay, so that's the information that I've extracted from here. And I need to think of the equations line that fits that. Right, parallel. If two lines are parallel, look at them. What do they have similar? They have the same gradient. What was the gradient of this equation again? The gradient of this equation was negative a half. So therefore the gradient of my equation I'm trying to find will also be negative a half. This is the point 0, 7. 0, 7 is on the y-axis. Therefore, for this equation that I'm working with, that I'm trying to find, this 7 is actually the y-intercept. With that in mind, I know that my equation I'm looking for is y equals negative a half x add 7. And that is how I calculate that part C. Feel free to have another look at that video and see how that goes. Alright? We're just about off shot. Let me just move that a bit. Okay? Excellent. Okay then, so that's the end of the second part. It was a little bit rushed towards the end of it, but if you still need some extra help, I've got a couple other questions here. So here's one question, which says find the equation of the line that passes through A and B. So obviously this cuts the y-axis at 3, so you know the C value will be 3, and finding the gradient of this positive line would be to draw that triangle that you can kind of see my finger tracing here, knowing that the difference in x will be 2, the difference in y would be 1, 2, 3, 4, so it's 4 divided by 2 gives you a gradient of 2, so m equals 2. So your answer would be y equals 2x plus 3. The gradient of 2 crosses through at 3. Alright, so hopefully that's clearer there. Bit slower for you. And then also looking at this with that parallel and perpendicular and all sorts of things going on, here's another question where you might have lots of different lines on one picture and have to assign the right equation to the right line. So the top one is A and it says y equals 2x, so I'm looking for a line that is positive, but it hasn't got a C value, so therefore it must cross the x-axis, the y-axis at 0. So that's the only one that's positive and crosses at 0, so line S must be equation A. Equation B is y equals 3 take away 2x, so it goes, so this has got a -2 gradient and crosses at 3. The only graph that's going down as I look at it from left to right is this one here, and it crosses at 3, so that P must also be equation B there. Alright, so kind of if that kind of makes sense, you're on the right tracks. Okay, so again, thank you to Ella and Katie for this request. I'm sure this video is gonna help a lot of people. Yeah, this is B-Dog out with my cathedral projects all going well. See you guys soon.